Plastic molecules take up less space when they are cold relative to when they are hot, 99.999% of the time. With a few exceptions, mainly including the liquid crystalline polymers, plastic will shrink in a mold. If we look at the plastic molecule, we will see that when it is hot it occupies a certain space or volume, and for reasons of explanation let's compare the molecule to the size of a basketball. As the plastic cools, the molecule gets smaller and now is the size of a soccer ball. When plastic is injected into the mold, a certain number of molecules are forced in between the space formed by the cavity and core. Once the gate freezes, no more plastic can enter that space. Therefore, when the plastic cools and changes from the basketball size to the soccer ball size, the plastic part becomes smaller. To accommodate this in a mold, the mold designer must include a factor called shrink. This is expressed as a shrink factor, either as percent, inch per inch, or millimeter per meter. Amorphous materials typically shrink more consistent and less than semi-crystalline or crystalline plastics. Fillers, reinforcements, additives, colorants, and other factors will affect the shrink rate of plastics. Part features, thickness of the wall, part geometry, distance from the gate, and flow orientation can also affect the shrink rate of the given plastic. Another contributor to shrinkage of plastic will be processing conditions, especially on the semi-crystalline and crystalline plastics. Higher melt temperatures, higher mold temperatures, less packing pressure, less injection speed, lower packing times, and shorter cycle times can contribute to increased shrinkage. Opposite process conditions typically will lessen the amount of shrinkage. Whatever the desired shrink rate is determined best for the plastic, part, and process conditions. It then must be applied to the mold's plastic forming areas. Occasionally, more than one shrink factor is used in a mold relative to flow orientation. The shrink factor is applied to each dimension, be it in the X, Y, or Z direction, and applies to all part features including radius. The only part feature that shrink is not applied is to an angle. An angle will not change due to part shrinkage.